The eyes of the world now look into space, to the moon, and to the planets beyond. And we have vowed that we shall not see it governed by a hostile flag of conquest, but by a banner of freedom and peace. We have vowed that we shall not see space filled with weapons of mass destruction, but with instruments of knowledge and understanding. For space science, like nuclear science and all technology, has no conscience of its own. Whether it will become a force for good or ill depends on man. But I do say that space can be explored and mastered without feeding the fires of war, without repeating the mistakes that man has made in extending his writ around this globe of ours. We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
It's one small step for man, one giant leap for mankind.
When it comes to understanding the universe, we are only beginning. Humankind continually searches for patterns, trying to figure out, what is the universe made of? How does it work? How does our planet, our solar system, our galaxy fit in with the other pieces? And what don't we know yet? Helping us discover more pieces of the puzzle will be a new instrument on board the International Space Station, called the Alpha Magnetic Spectrometer, or AMS. AMS is not a telescope. Rather than looking at space, it will sift through space, studying the high-energy particles of cosmic rays. From the unique vantage point of Earth orbit, the AMS experiment has the potential to answer questions about the origins of our universe. The study of high-energy particles might help in the search for dark matter and antimatter in the universe. Nobel Prize-winning scientist Professor Samuel Ting, well known for groundbreaking particle physics work on Earth, has collaborated with an international team to create the Alpha Magnetic Spectrometer, a high-energy particle detector that takes particle science into space. With over 300,000 data channels for detection and over 600 onboard microprocessors to analyze the data, the AMS is sponsored by the Department of Energy, and scientists from 16 countries lent their expertise to create it. Parts from around the world were sent to CERN, the European Organization for Nuclear Research, in Geneva, Switzerland. NASA had the job to figure out how to get the 15,000-pound experiment into Earth orbit and have it operate in the hostile environment of space. The AMS was finally sent to the Kennedy Space Center, where it was ready to fly on board a space shuttle, the final large component of the space station to be sent on one of the last shuttle flights. Part of the shuttle crew is European Space Agency astronaut Roberto Vittori, who will operate the shuttle arm to grasp the AMS from the shuttle payload bay.
That means that I will have the responsibility with the shuttle robotic arm to take it from the payload bay and offer to the station. But behind that specific operational task, there is a very long history. I started about 25 years ago to study physics, to think about space, to think about the universe. And the specific of the search of the antimatter was one of my main and deep interests. It may appear as a very strange coincidence that today I will be the one to take this unique piece of hardware, take it from the bay of the shuttle and give it to install on the station.
For the AMS, there are many benefits to having a fully functional space station as your home.
So AMS weighs 15,300 pounds. Most of that is science experiments. We do not have to carry our own power. We do not have to carry our own data systems to transmit that data back to Earth, because all of those systems are provided to us by the space station. It's a perfect example of how you can utilize the capabilities of the International Space Station to fly groundbreaking science experiments.
So how exactly does the AMS work? One thing it is not is a telescope. Telescopes measure photons, packages of light, both visible and invisible to the naked eye. This type of astronomy has given us most of our knowledge of the universe thus far. But the cosmos speaks to us in languages other than light. For the AMS, this will be the first time scientists study charged particles. Exploding stars and other celestial phenomena are thought to produce cosmic rays which travel across the universe and can wash up on the shores of our planet. The rays are composed of charged particles, but many of these are absorbed in our atmosphere, making it impossible to study them on Earth. But outside our atmosphere, on the space station, the AMS will be able to sift through these particles, helping us search for antimatter, dark matter, and the stuff of which the universe is made. A particle will pass into the AMS. Layer upon layer of detectors tells us the mass, energy, and velocity of the particle. Other detectors tell us which direction or path the particle took as it passed through the AMS. At the heart of the unit is a magnet that will make the particle curve one way or another, telling us whether it is matter or antimatter. And just how quickly does all this particle detection happen?
Faster than I can snap my fingers. Nanoseconds. In nanoseconds. AMS gathers data at a ridiculously large rate. We will see about 25,000 hits per second of cosmic rays coming into the aperture of AMS.
8, 7, 6, 4, 3, 2, 0, and liftoff for the final launch of Endeavour, expanding our knowledge while expanding our lives in space.
Houston, Endeavour, roll program.
Roger, roll, Endeavour.
Houston is now controlling. Endeavour beginning to pull over onto its back. The roll program underway as Endeavour begins a heads-down position on course for a 51.6 degree, 136 by 36 statute mile orbit. Three engines now throttling down as Endeavour passes through the area of maximum dynamic pressure on the vehicle in the lower atmosphere. Approaching 1 minute into the flight.
Endeavour, go at throttle up.
Roger, go at throttle up.
Endeavour's three main engines now back at full throttle, all three engines in good shape. Endeavour's already traveling 1,300 miles per hour at an altitude of 11 miles downrange from the Kennedy Space Center, now 12 miles. At liftoff, Endeavour fully fueled, weighed 4.5 million pounds. It's already lost half that weight in propellant now, burned that weight. The next event is burnout and separation of the twin solid rocket boosters. That upcoming here shortly at the 2-minute 3-second point. Those boosters are burning 11,000 pounds of fuel per second. And standing by for separation of the solid rocket boosters.
Now you can see Venus.
Do the astronauts go there?
Not yet. Maybe someday. In fact, there are some really smart scientists who are working on something called antimatter to power spaceships into deep space. And all the fuel that they'll need, well, it'll fit in something about like this.
Cool. Where do they do that?
Washington State University.
Go Cougs.
Washington State University, because the world needs big ideas.
At any given moment, about 1,800 thunderstorms are in progress somewhere on the globe. New observations by NASA's Fermi Gamma Ray Space Telescope show that thunderstorms make antimatter. The process starts with a terrestrial gamma ray flash, or TGF, an intense pulse of gamma rays originating from thunderstorms. These dots mark TGFs observed by Fermi's Gamma Ray Burst Monitor during the spacecraft's first 8 months of operations. Researchers estimate that there may be as many as 500 TGFs each day. On December 14, 2009, as Fermi passed over Egypt, it spotted a TGF produced by a thunderstorm in Zambia. The TGF was over the spacecraft's horizon, where Fermi couldn't see it. So how could Fermi have detected it? Scientists believe that the TGF process begins in a thunderstorm's intense electrical field. Electrons within this field become accelerated upward. Above the storm, where the air is thin, the electrons can ramp up to speeds nearly as fast as the speed of light. When these ultra-fast electrons encounter an atom, they emit gamma rays. Very rarely, one of these gamma ray photons grazes an atom and transforms into a pair of particles. One, an electron, is normal matter. The other is antimatter, the electron's opposite, called a positron. The gamma rays travel in straight lines, but the charged particles spiral along lines of Earth's magnetic field. And that was the route to Fermi. The particles created by the TGF rode upward on magnetic field lines, and then struck the spacecraft. The positrons annihilated when they struck electrons in Fermi, creating a flash of gamma rays. For an instant, Fermi became a gamma ray source, and set off its own detectors. A fraction of a second later, some of the particles were bounced back along the same magnetic field line. They again passed through Fermi and again produced gamma rays. The spacecraft has observed this phenomenon on at least 4 other occasions. So the next time lightning flashes and thunder roars, remember, you may be witnessing antimatter in the making.
Researchers have found a band of antiprotons ringing around the Earth, adding one more to the list of particles Earth holds within its magnetic field. Cosmic rays constantly rain in from space, colliding with Earth's atmosphere and creating a spray of new particles. Scientists have observed antiparticles before, but this is the first time antiprotons have been observed. Many of these particles become trapped inside Earth's Van Allen radiation belts, the donut-shaped zones around Earth where particles swirl around the magnetic field. The find, described in astrophysical journal letters, confirms theories that predicted the particle. The University of Rome detected these particles using Pamela, a cosmic ray detector attached to a Russian satellite. The satellite orbited through the South Atlantic anomaly, allowing the study of geomagnetically trapped particles in the inner radiation belt. Between July 2006 and December 2008, Pamela detected 28 antiprotons trapped in the spiraling orbits around the magnetic field sprouting from the Earth's south pole. According to researchers at Italy's University of Bari, the band is the most abundant source of antiprotons near the Earth. The find could one day open the door to fueling spacecrafts with the exotic particle, an idea already being explored by NASA's Institute for Advanced Concepts.
A lot of people are doing nothing more than getting huge quantities of mass and see if they can get a gravity wave to cause things to move. Well, that isn't what we're talking about at all. So I wondered if gravity could be related to its cousin magnetism. And so I found that when I take two magnets together, I have some neodymiums around here that I'm actually afraid of.
They're so strong.
They can danger you. But anyhow, you take a magnet, you go to put them together and they go clunk, right? But you take one of them, move it around, and all of a sudden it doesn't want to go together.
The repulsive.
So I got, I ordered one at $5,000 a piece, with a 1/4-inch hole through between both of them, and I put a brass bolt and I tightened them down, forcing them together. And then I put them together in a thing that looks kind of like a rock. Okay, and then I got another one that didn't have magnets in it. And Galileo, in all his endeavors, he went up to the Leaning Tower of Pisa
and dropped
and he dropped a big rock and a small rock. And his buddy down at the bottom kept telling him that the large rock and the small rock arrived at the same time.
Jim, we copied both solar wind and penetrometer drum in the ETB.
Not quite yet. I haven't put the solar wind in yet, but I will shortly. I want to watch this. I have a good picture there. I've got
beautiful picture, Dave.
Well, in my left hand I have a feather. In my right hand a hammer. And I guess one of the reasons we got here today was because of a gentleman named Galileo a long time ago who made a rather significant discovery about falling objects in gravity fields. And we thought that where would be a better place to confirm his findings than on the moon. And so we thought we'd try it here for you. The feather happens to be appropriately a falcon feather for our falcon. And I'll drop the two of them here, and hopefully they'll hit the ground at the same time. How about that? Which proves that Mr. Galileo was correct in his findings.
Superb.
I got 9 guys that were not educated and didn't have pre opinions on anything, and I dropped my 2 rocks, and I said, what I would like you to do is, I told them what I'd like you to do is I would like you to take whichever one arrives first, get it in your hand, and when I come down the elevator, hand it to me. Now they looked identical, except for
and nobody knew it was inside?
No, absolutely not. All the 9 times that I tested it, it's as though the one with the opposing magnet field extending out 3 feet on each side. I actually measured how
big the field is.
How big the field was, and on each side of one rock, I had a total of 6 feet. At any rate, the other rock arrived first.
Which one arrived first?
The one that had no magnetic field in it.
So you were able to cancel out gravity to a certain degree. You were able to cancel,
precisely,
reduce the mass gravity effect.
Precisely.
By opposing fields.
Isn't that nice? You bet. And got 9 signatures and I always skip. You
did that at Lockheed. What year was this?
Oh, at least 8 years ago.
This is the actual document of Boyd's where he proved that by altering the field in a falling body, the magnetic field, it reduced its mass gravity equivalent and canceled out the effects of gravity to a certain percentage. And he did a building 500 drop test conducted from a height of 59 feet. The location is in White Settlement, Texas, and the time was 12:20 p.m. and this was in 1995, December 12th. Nobody knows this.
I know it.
So gravity, mass gravity is not, you can alter it.
Well, gravity within itself has to have, gravity goes through anything that is solid and anything like iron or anything else. but it has to have a magnetic component, which may be canceling out within itself. But as soon as it got around my rock, it all of a sudden recognized the presence of my rock.
One of Einstein's students tried to merge electromagnetism and gravity, and he rejected it. But he didn't have an experiment like you did.
No, I understand. I know that.
Yeah.
But see, nature never uses English. It doesn't speak. It doesn't speak any language. But yet it's talking to us all the time.
Right.
And the key thing is to identify what it's saying.
David Madeira with Hemp Technologies. This is our first house in the United States. It's permitted. What you've just seen is the mixture. The mixture is the most important thing. That must remain consistent. As you can see from this wall, we do it in sections. Now these sections have to fit together, and that consistency of the mix is crucial. Now we did these on last week. We can take down the forms now and move them up. This is our big window here. We'll lay the bottom plate in it, and then this will be protected. So what we're using here is recycled plastic in reusable plastic shutter forms that lock together tight. Sometimes we have to screw them directly into the framing, but pretty much they'll unlock, and then we use them on the outside. For this bottom layer, we need to leave that shuttering on for 24 hours. And after 24 hours, we can remove that first layer of shuttering system. And then we take the bottom shutters and we move them up on top. Now, in the perfect world, we'd have enough shutters to do both sides. But right now we have to keep reusing them to go around the house. So with these forms, with regular concrete, you have a slumping that causes the bottom form to go out. With hempcrete, you do not have any of this slumping, so you don't have to worry about taking the form off too early. And with concrete, what would happen is pushing the form out. And that's why your forms have to be a lot stronger. And in this case, because we don't have any slump, we don't have to worry about that. Okay, so what we have here is the hemp shiv, or also called the hurd, which is the internal part of the stem of the plant. And that's mixed with a lime-based binder. And so with that lime-based binder and the hemp, we've got a negative carbon footprint. Now the difference between lime and concrete is that lime you don't have to heat up as much. Concrete you have to heat up to almost 3,000 degrees, which takes a lot of energy and does very poorly on the carbon footprint, whereas lime does much, much better. Now this binder, using the lime and the hempcrete together, you have a breathable wall, but yet air doesn't pass through, so you have a much more thermodynamic situation. Major differences between this and straw bale is when straw bale gets wet, it doesn't do as well as this. When this gets wet, it just dries itself out naturally because of its breathing capability. And so you never have mold, you never have dry rot, and you never have termites. And so this whole wall is going to breathe. So the cellulose properties of hemp are so much better than straw. Now there might be some plant out there that's even better, but we don't know about it. Basically what this does is, because of the lime-based binder, not only does it have a carbon negative footprint, it will pull carbon dioxide out of the air after the house is built, because the lime is trying to go back to being a rock, and it needs carbon dioxide to do that. That means this wall is going to get harder and harder and harder. Over time, it's going to petrify. So these walls will last for thousands of years, not 40 years like what we're used to building. See how well in the winter conditions the hempcrete has held up. We've had freezing down to 8 degrees Fahrenheit here, back up to 32, back down. It's gotten to 40 degrees, and it's done extremely well in this weather. So once it warms up, we'll put the finishing render on it.
Cannabis hemp is the #1 food, fuel, fiber, paper, medicine out of any plant on earth.
Amongst the thousands of products made from hemp, one of the most extraordinary is Henry Ford's plastic car. Built in 1941, it contained cellulose fibers derived from hemp, sisal, and wheat straw. The plastic was lighter than steel, yet could withstand 10 times the impact without denting.
Now today we're able to produce over 50,000 different things from that plant. Practically everything you're looking at right now can be made from hemp. Now 1 acre is only about 65 square meters. It's not a very big area. But 1 acre of hemp will produce 500 gallons of ethanol. Well, that'll run your car a long ways. But there's new enzyme processes out right now that they tell me that they can get as much as 1,800 gallons of ethanol per acre. Now, 1,800 gallons would heat your house, heat your hot water, run your car, and you'd have a few hundred gallons left over. And don't think for a second that your car can't run on alcohol, because right now, over half the cars in Brazil are running on alcohol made from sugarcane. And hemp is a superior plant to sugarcane because it has the highest cellulose content. It'll produce the most alcohol by weight.
At Poet, we have a unique way that we process biomass into ethanol or cellulose into ethanol. We do that by first collecting the stover, which in this case is corn cobs and some of the light husks and leaves that come off the corn stalk. We then process that at our facility, basically take it through a milling process first. It then goes on to a pre-treatment step where we break down those particles even further, through a enzymatic hydrolysis step where we convert the cellulose and hemicellulose into sugars. Those sugars then move to a fermentation stage where over time they're converted to ethanol. That ethanol is then separated from that mixture, and the remainder, which becomes a byproduct, then can be used to power not just the cellulosic plant that we're operating to do this whole process, but also can be used to power other facilities that could be located next door, such as a grain-based ethanol plant or an electric generating plant.
The American government government and the Canadian government had this plant listed as a non-medicinal plant. Now, if you look it up, the American government since 2003 have had medical patents on that plant. Medical patents for a non-medicinal plant? Does that make any sense to you?
My name is Rick Simpson, and I'm here in the beautiful city of Rijeka to speak about the use of hemp medicine. What's truly happened here is years ago, big money has manipulated governments and all kinds of organizations into keeping this plant away from the public because it's so medicinal. And not only that, it's an energy source. It can feed the planet too on top of that because the hemp seeds are one of the most nutritious things you can eat. It's endless what we can do with this plant, and then we will not be at the mercy of these big energy companies. We can all supply our own energy needs. This is the greatest medicine on this planet for treating all types of diseases like cancer, multiple sclerosis, arthritis, chronic pain. I could sit here and go on for the next hour because in reality this medicine works on all medical conditions. It promotes full body healing, and it doesn't just go after like the condition you have. Like when you go to the medical system and you have say a big tumor, the medical system tries to treat the tumor. They're not treating the underlying condition that's allowing your body to create that tumor. But when you take this oil, it goes after the underlying condition, plus it goes after the tumor. And I mean, we've just seen miraculous results with the use of this medication. And where it's harmless, why shouldn't we all have access to it? There's no reason that this plant couldn't be used to heal the world. And this is the direction we have to go. We have to take back our freedom, and we have to try to get rid of a lot of this pollution that's ruining this planet. Our planet is poisoned. It's in a horrible situation, especially like with that big Gulf oil spill in the Gulf of Mexico. Then you've got Japan spewing radiation for, well, heaven knows how long. That'll go on. And on top of that, this dependency we have on all this fossil fuels, again, the fossil fuels are poisoning our planet.
The biggest design challenge of the solar arrays was probably just their size. Each solar array is 28 feet long, and so we have 3 of them. And so when the solar arrays are fully deployed, the Juno spacecraft is almost 60 feet in diameter across the solar arrays.
Getting those big solar panels to work the way we expect them to work and produce the amount of power we need, that's been a bit of a challenge.
The solar arrays are pretty interesting. When we deploy them, they'll be generating about 12 kilowatts of power. As we get further and further from the sun, that amount of energy will drop off until we finally get to Jupiter, where we're only generating 400 watts. It's not even enough to run a hairdryer.
Generally, with space exploration, you're pushing the envelope of technology.
Solar panels have improved a bit. The instruments have improved a bit and can run on less power.
A professor at Princeton named Gerard O'Neill conceived of the idea of putting large colonies in space, large artificial places where people could live and work. And what we did was to gather together a group of university people to look at the problem of how you build the very first colony.
This is Taurus, the concept that has evolved from the work of these teams of scientists and engineers. They believe the huge space colony could be built before the year 2000.
The space colony has the ability to provide a facility in space where human beings can conduct fruitful industry. The amount of sunlight that is present in every square mile of space is enormous, and that provides enormous energy. One of the things that one can do is to build very large solar power stations which collect sunlight.
The Earth-like environment would even simulate our gravity as the wheel revolves once each minute.
The other materials like food and water are maintained locally within the colony. The initial supplies are brought up from Earth, and then eventually the colony becomes self-sustaining by utilizing the sunlight that's available all the time in space, by optimizing the temperatures, by not having storms or things like that that damage crops. And we increase the carbon dioxide levels a little bit so the plants grow a little faster. By playing all these tricks, we're able to generate this fairly efficient farm in our design.
From dairy farms to manufacturing, the concept of living and working in space is a possibility with existing technology. That new space home, located 250,000 miles from Earth, would even have a far-out address.
George Washington, Thomas Jefferson. These were the founding fathers of the United States of America. They were hemp farmers. George Washington is very well recorded that George Washington used to like to sit out on his veranda at night and smoke his hemp in his pipe. Now, these are the same people that authored these wonderful documents like the Declaration of Independence, the Constitution. So it appears that the hemp didn't affect their thinking abilities. Thank you.